Good morning friends, welcome back to my YouTube channel Medical Clubs by Dr. Srinidhi Kumar Acharya. Please don't forget to subscribe to my channel and also please give your valuable comments. You can also visit the playlist. In the playlist I have provided almost all the topics in a very systematic order, and you can also make use of it for the systematic study. Anyway, my dear friends, we have been discussing about DHD, differential sexual development, and we are talking about congenital adrenal hyperplasia, and in the last class we have seen some of the basics. And in the basics we have seen that congenital adrenal hyperplasia means that condition where actually the adrenal gland will undergo hyperplasia, but there is no proper production of the adrenal hormones, especially two of the hormones, that is aldosterone and as well as cortisol. So they are not produced at all, and as a result of this there will be overproduction of the androgens, which leads to the ambiguous genitalia like conditions or early virilization. But we need to understand this point very clearly because this itself is the base. Therefore I want to take it in detail actually what happens. Now for that we have to clearly understand this particular chart. Now, as I told, the precursor for the production of the adrenal hormone is nothing but cholesterol. Once the cholesterol enter inside the adrenal gland, and the first step is that cholesterol undergo the side chain cleavage. Cholesterol side chain cleavage that we have discussed in the last class, and there is a protein which is also called as a star protein, which is also a rate limiting protein. Now, because cholesterol enter inside the side chain cleavage, and as a result the changes take place. The first step which takes place is cholesterol is now get converted into pregnenolone. Pregnenolone is the first thing which is formed, and then this pregnenolone is get converted into progesterone. So conversion of the pregnenolone into progesterone is by the help of the enzyme 3-BHSD. Okay, now next this progesterone will be converted into 11-deoxycorticosterone. This conversion taking place by the help of 21-alpha hydroxylase enzyme. Okay, this conversion is taking place by the help of the 21-alpha hydroxylase enzyme. Next, 11-deoxycorticosterone is converted into corticosterone. This conversion also takes place by the help of another enzyme which is called as 11-B hydroxylase. 11-B hydroxylase. Okay. Now further, the corticosterone is converted into next form, that is 18-OH corticosterone by the help of 11-B hydroxylase enzyme again. Now this 18-OH corticosterone is converted into aldosterone. Okay, 18-OH corticosterone is converted into aldosterone by the help of aldosterone synthase and also 11-beta hydroxylase enzyme. So this is the whole pathway. How the aldosterone, one of the adrenal hormone, is formed. I hope you understand. Okay. Now these many steps are there. There may be problem at any step which leads to the problem. Anyway, now we come to the next part. How the cortisol is formed. See, now we know that the pregnenolone is formed, and as well as from the pregnenolone again the progesterone is formed. Okay. Now what happens? Some portion of the pregnenolone and the next step, some portion of the progesterone, both of these, when they acted upon by an enzyme called as 17-alpha hydroxylase enzyme, see shown in the orange, 17-alpha hydroxylase enzyme, so they are converted into their next form. Like pregnenolone, when it is acted by 17-alpha hydroxylenone, then it leads to the formation of 17-alpha OH pregnenolone, And progesterone, when it is acted upon by the 17 alpha hydroxylase, it is converted into 17 alpha OH progesterone. Okay, so from there only the next pathway starts. Now this 17 alpha OH progesterone, when it is acted upon by another enzyme called as 21 alpha hydroxylase, it is converted into 11-deoxycortisol. 11-deoxycortisol. This 11-deoxycortisol again acted up by an enzyme called as 11-beta hydroxylase, just like here in aldosterone. It is also acted upon by 11-beta hydroxylase enzyme. This converts this 11-deoxycortisol into cortisol. 11-deoxycortisol into cortisol. So this is how the cortisol formed. Okay, I hope you are very clear. How the aldosterone is formed, I have given this pathway. Okay, how the cortisol formed, these first two precursors of this aldosterone, that is pregnenolone and progesterone, they themselves they divert the path to some extent, acted upon by another enzyme called as 17 alpha hydroxylase, and that leads to the formation of these two substances like 17 alpha OH pregnenolone and 17 alpha OH progesterone. They in their next step, after the action of 21 alpha hydroxylase enzyme, converted into 11-deoxycortisol, and this 11-deoxycortisol acted upon by 11-beta hydroxylase enzyme, and then the cortisol is formed. Then there is formation of the cortisol. Now in case of congenital adrenal hyperplasia, what we are witnessing is there is no production of aldosterone and there is no production of the cortisol. There is no production of the aldosterone and there is no production of the cortisol. Now what happens to this pregnenolone and progesterone? They are already formed, isn't it? In the next step there is no formation. But these two precursors which are formed, now there is, anyway they should be get utilized. Then they go into the next pathway. These are now, see, pregnenolone and progesterone here, and 17 alpha OH pregnenolone and 17 OH progesterone here. Okay, so they are unfortunately not get converted into their next state. What may be the most common possibility that they are not converted into their next step? If there is a deficiency of 21 alpha hydroxylase enzyme. Suppose progesterone is formed here, but 21 alpha hydroxylase enzyme is absent, then it is not converted into its next stage, it remains in the blood, isn't it? Or in the adrenal gland. Here also, here, when they converted into this form, 17-OH progesterone and pregnenolone, there also for their next conversion into cortisol, we require an enzyme called as 21 alpha hydroxylase, same enzyme. That is absent, so that is also not formed. Now these two things are remaining in the blood or adrenal gland, and the only pathway left for them is they should be get converted into next pathway. So these remaining precursors, so which are not utilized by these enzymes, so they remain in the blood, they are going on accumulating, and now they are converted to DHEA and also androstenedione. They are converted into DHEA and androstenedione. So this is the androgen pathway. See, this is aldosterone, this is cortisol, this is androgen. These two are not formed. Precursor is loaded there. So what to do? They go into the next pathway here. So here, so they will be converted into androstenedione. Androstenedione. To make it very clear, see, this is you just look into this particular pathway. Okay, so what I told, 21 hydroxylase deficiency is there, so progesterone is not converted into the next state and aldosterone. So here also this 17 OHP progesterone and this pregnenolone, that's not converted into cortisol because of there is a deficiency of one enzyme called as 21 hydroxylase deficiency. Now what is left here? So when this deficiency is there, all these precursors they enter into the next pathway, and there is formation of the androstenedione and also DHEA, which later forms the formation of a testosterone. This androstenedione later form the testosterone. So naturally what happens when aldosterone and cortisol is not formed, naturally there is more amount of testosterone is formed because these precursors are there. But to convert this precursor into next stage of the pathway, this enzyme is absent. So 21 hydroxylase deficiency, that leads to absence of aldosterone, absence of cortisol, but more production of androgens. So this is the actual pathway. Okay, so this is actual problem which is happening in case of congenital adrenal hyperplasia. Therefore, we say in congenital adrenal hyperplasia, there is no production of aldosterone, there is no production of cortisol, but there is a excess production of testosterone or androgens. I hope you understand this point very clearly. The same thing is mentioned here also to make it very clear. Okay, testosterone is formed. Okay, the last part here, that the DHA is there, androstenedione is formed, androstenedione is converted into testosterone, testosterone can be get converted into estradiol, or androstenedione can be converted into estrone, estrone can be converted into estradiol. Now what happens, suppose in a female baby, there is no production of the aldosterone, there is no formation of the cortisol because of a 21 alpha hydroxy deficiency. So naturally there will be more formation of the androstenedione. When there is more formation of the androstenedione, there is formation of the testosterone. Okay, this presence of the testosterone is totally an unwanted thing for a female baby, but it is formed in excess. The reason is these two are not formed, therefore the pathways get diverted. So more amount of the testosterone leads to virilization in case of the female baby. For the male it is okay, no problem, but for the female it leads to virilization and ambiguous genitalia. Okay, now suppose if so this is what we have to understand by this particular part. Okay, so I want to make this point very clear because this is the base for the next thought. And in the next class we will understand 21 alpha hydroxylase deficiency. 21 alpha hydroxylase deficiency, so that is nothing but this particular enzyme 21 alpha hydroxylase deficiency, and why this happens, and what is the actual cause for this, and what are the clinical presentations. Okay, so that we'll see in the next class, because 21 alpha hydroxylase deficiency itself is the main cause for non-production of aldosterone and cortisol in case of congenital adrenal plasia. Naturally it leads to the more formation of the androgens. So in the next class we will see 21 hydroxylase deficiency and its clinical presentation. Thank you very much.